And welcome to Mission Control Houston. And again, joining us is a special guest, Mike Barratt, a veteran astronaut of the International Space Station and a doctor to boot. Welcome, Mike.
Thanks so much, Kelly. Great to be here.
Great to have you here. Now, the reason we had you in this week is because very early in the week, the crew on board the space station was working on some vision experiments on orbit. I know you know a lot about these. You've been involved in the experiments themselves. Can you tell us a little bit background about why it's important and what we're doing about it?
Well, sure, Kelly. I have a lot of vested interest in this on many levels. First of all, being a medical doctor and a space medicine specialist, but second of all, having experienced this vision issue myself in 2009 during a long duration flight on station, I noticed my visual acuity was getting a little different. It was shifting towards the distant vision. And myself and Bob Thirsk, another physician, we decided to do eye exams on each other, and we found a little bit of optic disc swelling. And with that, we actually talked to our specialists on the ground, and they were able to fast track some hardware up there, which allowed us to get very detailed camera images of the back of the eye. And lo and behold, since then, we've discovered this constellation of findings, if you will, that include a lot of things with very, very serious anatomy to us. And so that includes swelling of the optic disc and distension of the sheath that goes around the optic nerve, and of course the vision changes, which are just shifting a little bit towards the far sided, and a few other changes of the retina itself, and possibly an increase in the pressure inside the head, the central pressure, as we call it, intracranial pressure. So the interesting thing here is that this has probably been going on for a very long time, and because of ISS and the tools that we've had available up there, and of course because of our accumulated flight experience, we've been able to characterize this now in ways that we couldn't before. It was right under our noses, but now we're getting, I think, a very good understanding of it. The other aspect of this is that it's very, very highly prevalent, meaning if you look at many different flyers, and one of our series actually looked at 26 out of 27 both space shuttle and space station flyers. We found some of these findings in 26 out of 27. So it's a very high prevalence rate. And what that tells you is that this is an aspect of adaptation to zero gravity that almost everyone goes through, which we just weren't aware of for all this time. But in some people, of course, it's expressed a little bit more seriously in some of the vision changes. So we are mounting a very aggressive effort to understand how this happens, why it happens, and over what time course it happens. So the experiments we've been doing this week are part of that effort. Now, we have a kind of a dual approach to this. We do an operational monitoring profile where we're looking at everybody as just a good medical metric to see how people do. So we look at onboard ultrasound to look at the eye shape change, to look at the optic nerve. We do visual acuity tests to see if there's any shift in people from the near to the far sided. And we have a very special device called an optical coherence tomograph, or optical coherence tomography, which essentially takes the layers of the eye and shows you their structure in very minute detail. It's a fantastic device.
And that's what the crew this week was working with.
And that's what the crew is doing. And that's a new device on orbit for us, but it helps us to characterize this set of findings in a way that is very detailed and something that we need a big detail or a well-equipped laboratory to perform. And of course, we do imagery of the back of the eye as well.
Well, let me ask a really simple question. Does it hurt?
Well, no. That's a good question. No, it's just you're staring at a bright light and you're staring at a target, and there's a little bit of a laser scan, and it's not bad at all.
I guess I was really referring to the changes in your eye shape and these things that you're looking for. Do the symptoms, are there painful symptoms? You get headaches or anything like that are associated with that? I know when I have eye problems, sometimes I'll have a headache.
So that's a great question, and I think it's a truism that one of the reasons we've missed this so long is that it really doesn't have a lot of symptoms. And one of the fascinating aspects of it is if you look at a ground population where people have increased intracranial pressure to the point where you see these anatomical changes, they are sick. They do hurt. They have headaches, nausea, vomiting. They can't walk straight. There's all sorts of things that cause them to come to the doctor. The only symptom we have is a farsighted shift in some people. Otherwise, we're fully correctable and we're fully functional afterwards, during flight and after flight. There's many reasons to have headaches in space, and so we do think about that quite a bit, but they don't seem to be coupled necessarily to this set of findings. And I think it's fair to use the word syndrome because it is a constellation of findings which we see consistently. So really the only symptom is the vision shift.
Okay. And I guess this would be really important for future exploration missions because if you get farther and farther away from the Earth and you don't have any way to get new lenses, you're going to run into problems doing your job if you can't see well.
Well, absolutely, and this is one of the new problems that we've just discovered, but it's critically important that we understand the mechanism and how to mitigate it or how to treat it, and that is absolutely something that we need to have in place before we go exploring. So with the space station, what we're hoping to find is the time course. Does this plateau over time and not get worse, or does it progressively get worse with time and zero gravity? Those are things that we absolutely need to know coming out of the station program.
Okay. I know when you came in today and you saw everybody on the screen, you were pretty jealous at what they were doing up on orbit. The last time we had this many people on the station without a shuttle present was in October 2009. I think you were on board then. What's it like being in such a crowd upstairs?
Yeah, absolutely. That was a very special time for a lot of reasons. But October 2009, I had been up there for 6 months already and was getting ready to come home. And we did the first mixed hand or direct handover where we had 3 Soyuz's worth of crew members up there. So 9 crew members on station. The interesting thing is we've had visiting shuttle crews where we could swell the population to 12 or 13. But you have the added volume of the space shuttle, which is quite large. And everybody sort of has their own quarters there on the shuttle. Whereas with the Soyuzes, you have a bunch of folks, you got 3 deposed individuals without crew quarters, and a lot of activity concentrated into the Russian segment. So it actually seemed quite a bit more crowded and busy when we had 9 than when we had 12 or 13. But it's a good time because a lot of dynamic flight activities are happening. And these are the things that make spaceflight exciting, make astronauts happy. So during this time period, that will include packing to go, readying the new Soyuz to return, spacewalk. All the experiments are coming to a head, and of course, people are winding down a 6-month shift up there. So it's a wonderful time, but it is quite busy.
All right. Well, Mike Barratt, astronaut, physician, veteran of the International Space Station, thank you so much for coming and joining us today.
My pleasure, Kelly.